So how do you take the Fourier transform of a function? Well, in order to understand that, you first need to understand that any function f of x can actually be expanded as a Fourier complex integral. So f of x can be written as 1 over 2 pi times the integral of e to the power I alpha x d alpha times an integral, say a function f of u times e to the power minus I alpha u du, and both these integrals can run from minus infinity to infinity. Well, now if I want to distribute this 1 over 2 pi to both these integrals, I'll get f of x equals 1 over 2 pi, but this time square root, times the integral from minus infinity to infinity of e to the power I alpha u d alpha times 1 over square root of 2 pi times the integral going over the same range again, f of u e to the power minus I alpha u du. Well, let me call this integral equation 1, and then I can divide both these parts. I can say that this is the part A of this integral, and then I can say that this is part B of this integral. So if I consider this part B, for example, then I can do a variable substitution. For example, I can say that u now changes to x. Well, in such a scenario, this integral right over here would transform to 1 over square root of 2 pi, going from minus infinity to infinity, because the limits wouldn't change obviously, of f of x e to the power minus I alpha x dx. That's great. I can define this as some function g of alpha and name this equation 2. Then I can just substitute this equation 2 back to part B of equation 1. Well, if I do that, this was our equation 1, and upon substituting this part B as g of alpha, we are going to get f of x equals 1 over square root of 2 pi times an integral going from minus infinity to infinity of g of alpha e raised to the power I alpha x d alpha. Let me just call this equation 3. Now g of alpha is known as the Fourier transform of f of x, and f of x is known as the inverse Fourier transform of g of alpha. So now if somebody asks you what is the Fourier transform of f of x, you just need to calculate the function g of alpha, which is given by 1 over square root of 2 pi times the integral going from minus infinity to infinity of f of x times e raised to the power minus I alpha x d alpha. Let me take a very simple example. Say you have a function f of x which is equal to 1 if mod of x is less than a, and is equal to 0 if mod of x is greater than a. And you are supposed to figure out the Fourier transform of this function. Well, if you look at this function f of x clearly, you can see that you do not have to worry about the second part of this piecewise function, because anyways it is 0. We only need to worry about the first part of this function. And if you are familiar with the properties of the modulus function, then you understand that the range is just x is less than a and greater than minus a. Therefore, the limits of the integral is going from minus a to a. Therefore, the Fourier transform of f of x would just be given by 1 over square root of 2 pi times the integral going from minus a to a 1 into e to the power minus I alpha x dx, which then transforms into 1 over square root of 2 pi integral going from minus a to a e to the power minus I alpha x dx. Well, this integral just gives you 1 over square root of 2 pi times 1 over I alpha with a minus sign times e to the power minus I alpha x going from minus a to a, which would simplify to 1 over square root of 2 pi times 1 over I alpha e to the power I alpha a minus e to the power minus I alpha a. With some further simplifications, you get that the Fourier transform of f of x is given by square root of 2 by pi times sine of a alpha divided by alpha.